So in our last video, we were looking at the structure of an atom. And just to recap, in the center of an atom, we have the nucleus, and that is made up of protons, which are positively charged, and neutrons, which are neutrally charged. Okay, and they're located in the nucleus in the center. We then have electrons orbiting in electron clouds around the outside. Now these outside electrons are loosely bound. They're called valence electrons, and they're able to bond with other atoms. They're readily lost. Okay, so if we were to lose electrons, we would actually have a balance. Our positive and negative charges would be imbalanced. So if we lost some electrons, we would have a positive charge overall. So our atom would be positively charged. A positively charged atom is called an ion. And if we were to gain more electrons, we would have a net negative charge. So our atom would be negatively charged. So electrons are the only ones that we can remove. So they actually cause things to be positive or negatively charged. So we're going to use this idea of electrons transferring, okay? Because objects become charged when electrons are transferred from one object to another or redistributed on an object. So we're going to, your learning intention for this slide is that you need to be able to explain charging by friction. Now, as I've said, the outermost electrons in an atom are the ones that are loosely bound, and they're easily dislodged. Hence, when we have some friction, okay, some rubbing, we can have a transfer of electrons. So, you're going to have a play around with this in a second, but if we have a rubber rod, okay, imagine you have a rubber rod right in front of you, and you rub some fur on it, okay? Once you've rubbed it, there's going to be a transfer of electrons, and the electrons are actually going to transfer from the fur to the rod. So the rod is going to have more electrons on it, and the fur is going to have less. If you were to rub a glass rod on silk, this swaps. Okay, we're gonna look at this. You guys are gonna do a little practical where you're gonna rub some objects with some different materials, different kinds of rods. So with the glass rod, if you were to rub silk on it, okay, the electrons actually transfer from the rod to the silk. So the rod now has less electrons and the silk has more electrons. All you need to know for now is that an imbalance of electrons results in a charge. So an excess of electrons, so more electrons will have a negative charge on the object, and a deficiency or less electrons will result in a net positive charge. So remember, electrons cannot be created or destroyed, they are simply transferred, and charge is always conserved. Okay, like energy, charge is always conserved. However, in order to charge an object, we need to put in energy. So energy is required to rub the rod and the fur together. Okay, so energy is needed to charge an object positively or negatively. And this energy can be provided by physically rubbing objects in order to remove electrons, thus creating equal but oppositely charged objects. Now, so basically charging by rubbing, pretty much the same as charging by friction. You guys all would have done this next little example in the past. So again, electrons can be transferred by friction, rubbing basically. So electrons can be transferred by contact. When a charged rod is placed in contact with a neutral object, some charge will transfer to the neutral object. So with a balloon, you've all done this tons of times. You've rubbed a balloon onto your hair. So initially the balloon was neutrally charged and your hair is neutrally charged. Now, when you rub your hair against the balloon, some of the electrons actually stick from your hair onto the balloon. Okay, now because your hair has lost some electrons, it now has a net positive charge. Okay, so there is more positive charges on your hair, and those positive charges are going to want to repel each other because they're like charges, and that's what results in the standing up of hair. Now, different objects have different affinities for electrons. Okay, so certain objects, the electrons are going to want to go from one object to another. Okay, now this is a chart of increasing affinity to accept electrons. So if you were to rub aluminium and rubber fur together, the electrons would transfer from the aluminium to the rubber fur. If you were to rub wool and rubber together, the electrons would transfer from the wall to the rubber rod, and so on and so forth. So they transfer in this direction. So these ones down here are more likely to accept electrons. You're going to, so you don't need to remember this table. If you ever get asked a question where, it might be, if you were to rub together an aluminium rod and rub it for which material will accept electrons. So if you were to rub aluminium and rub it for, the electrons would transfer from the aluminium to the rubber fur. You're now going to look at a bit of a, you're going to look at an investigation, so you can have a play around with one of these. Now I'm not sure if you've seen one of these before, but they are called an electroscope. And you're going to play around with a few different materials and try and charge this and see what happens. So this is called an electroscope. It's a device for detecting charge. Some of them, these ones, have a bit of a scale, so you can see how strong the charge is. These ones are called electrometers when they have some sort of scale. Now, basically, the parts of an electroscope, you have a metal plate at the top, okay? A metal plate at the top, a support stand connected to the plate. Now, it extends into the glass and the metal cylinder, and this we refer to as the needle. So this here is the needle, okay? You're going to basically bring objects up to this top, and you're either going to bring it close. So the investigation will give you a method to complete. You're going to bring the different materials close to this, and you're going to investigate how it affects the needle, okay? So the needle's free to rotate about its pivot point. There is an insulating plug between the outer case and the stand system. So basically you're going to charge different objects, and then you're going to see how they affect the needle, okay? So you're going to look at the electroscope investigation. So the electroscope investigation looks something like the following. Electroscope investigation, apparently I've gone blank. Making a detector, no. Electroscopes, electroscope investigation. So yeah, you're going to have some different equipment, the table, and you're going to be doing a bunch of different things, and you're going to be describing and trying to explain what's happening. Alright, let me know if you have any questions.